Okay, so let's do this DFA example, W, where W has at least 3 A's and at least 2 B's. So the easiest thing to do here is we can split this up into kind of 2 DFAs and then combine them. So if we say W has at least 3 A's is one DFA, and then we say that W has at least 2 B's is another DFA, we can kind of break it down into 2 simpler problems and it'll be easier to kind of conceptualize them combining. So let's do W has at least 3 A's first. So basically what we're going to do here is we're going to start with our initial state, as we always do. Let's call this 1. And then we want to keep track of how many A's we have, right? Because we need 3 A's. We want to count how many A's we have. So on A, we're going to go to a new state. And then nothing will really happen on B because B's don't matter in this context. B's do not matter at all. We don't need to keep track of B's. So on every state, B is basically just going to bring us back to where we already are. It's just going to loop. So on A, we're going to go to state 2. And then on transition A, we're going to go to a new state. Let's call this state 3. So now you'll notice what we're kind of doing here. If we're on state 2, then we have at least 1 A. If we're on state 3, we have at least 2 A's. There's no other way to get to these states other than to have an A and go here. There's no way to go backwards. We don't have any arrows pointing backwards. So what we can do here is just count another time and go to state 4. So now if we're on state 4, we know that we have 3 A's because there's no other way to get to state 4. And obviously on the other states, we can just loop on B because B is not really important. We're just going to stay where we are. And then on the final state, we know that if we're here, we're going to accept. As we have 3 A's, we need 3 A's to get here. So we're just going to loop on A and B on the accept state. So now what if we want to do at least 2 B's? Well, it's pretty much the exact same thing. You get the concept from the first one. So we're going to set it up pretty much the exact same as before, but we're just going to have one less state. So this is going to be our final state. I'm going to loop on A and B. And then we're just basically going to reverse the letters from the previous one because we're basically just counting 2 B's now. We were counting 3 A's before, and now we're counting 2 B's, right? So now we're on B, we're going to go to the next state. This means we have 1 B. And then on B, we're going to go to the next state, which means we have 2 B's here. So these are kind of our 2 DFAs, and we're going to combine them somehow. So how can we combine these? Well, you know, the most common approach would be to kind of have this grid, perhaps, where you're counting how many A's you have on kind of the horizontal axis here, and then you're counting how many B's you have on the vertical axis here. And then what you can do is, once you hit this, let's say that this is the point here where you have reached 3 A's on this side and 2 B's on this side, then you can accept, right? So this might be a little bit difficult to visualize if you're new to DFAs, so let me draw it out and it'll make a lot more sense. So let's set up how our DFA was before with the at least 3 A's part. So we're going to have our initial state, let's call this 1. We're going to go on A, remember, to our next state to keep track of how many A's we have, so state 2. And then we're going to keep doing this. I'm going to go to state 3, and then state 4. So this will basically count if we have 3 A's, and if we're on state 4, then we know we have 3 A's. And then let's add our loops. So we're not going to loop on B anymore, because now we're combining these. Now we're doing the whole entire thing. So we need at least 3 A's and at least 2 B's. So now we do care about our B's on this situation. So what we're going to do is we're going to have a second layer here, have a second layer of states where on B, we're going to go down to keep track of how many B's we have. It's kind of a 2-dimensional array of sorts in a little diagram. So on B, we're going to go here, let's call this state 5, right? And then we can kind of copy what we did above here. So on A, we go to state, let's call this 6. And then on A, we go to state 7. And on A, we go to state 8. And now we can kind of add this B transition onto all these as well. So this is going to be kind of our layout that we're going to go with. So if you'll notice here, let's say we have a string. Let me type in example string. So let's say we have AB, AB, AB. This fits our criteria because it has at least 3 A's and at least 2 B's. So what we're doing is we're going to, let me get a different color. We're going to go to A first, and then we're going to go to B, and then we're going to go to A, and let's just pretend the string ends here. So we have A, B, A. So we've tracked that we have, what position are we on the horizontal axis? We're on position 1, 2. On position 2, so that means we have 2 A's, and we're on position 1 on the vertical axis, so that means we have 1 B. And that's true, we have the string ABA. So this is kind of keeping track simultaneously of how many A's and how many B's we have. So we can kind of use this to generate the rest of our little diagram here. And you can kind of guess what's going on if you've been following along. We're going to create another row on the bottom, because remember, we need to track that we have at least 2 B's. So we're going to go to a third row here. If we're on the third row vertically, then we know that we have 2 B's. So that should be the end here vertically. So we're just going to kind of copy what we did above there as well. Let's call this 9, 10, 11, and 12. And then we can kind of put arrows as with B downwards, right? And then let's release it with A's. So you can see what's happening here. Let's kind of go through our string again. A, B, A, B, A, B. So A, B, A, B, A, and then this is going to be our accept state. Once we get here, we know that we have at least 2 B's, because to go down 2 rows vertically, we need B twice. That's the only way to go down vertically. And then to get across horizontally 3 rows, we need an A, because we only have A transitions going to the right. So we're going to loop on AB here, because once we have 2 B's and 3 A's, we don't really care what else we have, because we've already met the criteria. So we're just going to loop on that. We're going to make that an accept state. And then we can test this for a bunch of strings. Let me actually delete these pink lines so we can test this for some more strings and see where we went wrong, because this might not be complete. So let's put some other common strings. AAABB, probably the most common one. BBAAA. Let's do AABB. How about just AABA? And then one without enough A's, so AABBB. Let's try these and see how they work, okay? So AAABB. So A, should use a different color. Okay. So A, B, B. We land on the accept state, that's good. Okay. Now B, B, A. Okay, so B, B, A. We land on the accept state, that's good. A, B, A. So A, B, A. We don't land on the accept state, and that's right, because we don't have 2 B's, so that's good. Now A, B, B. So we go A, B, B, but we can't go any further, but we need another B, so that means our diagram is incorrect. So that means we need to add some kind of transition for a B here. Well, we know that if we're on this row at the very bottom, then we already have enough B's, like we've already met the requirements. So what we can do is we can just loop on B, because we already know we have enough B's, so we don't really care about any B's anymore. So we're just going to loop on B on the very bottom row here. So now if we go back A, B, and then we'll just loop on B again and return here, we see that that's correct. There's not enough A's to fit the requirements, so that's correct. It shouldn't be in the accept state, so that's good. But since we did this kind of looping on B here, you might notice we might need something on this side with the A's. What if we have 4 A's in this string? So let's add another string here, A, B. Let's try that string and see what happens. Okay, so let's try it on this new string. So A. We have nowhere to go on A, so what we have to do is we have to loop on A here. If we're on this far right column here, then we know we have enough A's, so same concept as before. We can just loop on A on all the far right columns here, on the far right states, because we don't really care about A's after we already reached 3. So now if we go back and try our string again, A, we'll just loop back here, and then we'll go B, and then that'll be on the accept state. So this diagram looks like it's correct for this language. W has at least 3 A's and at least 2 B's.